Okay. Now, can anyone say the difference between linear acceleration, centripetal acceleration, and angular acceleration?
So in linear acceleration, speed will increase, but the direction will remain same.
Speed will increase, but
The direction will be same.
very good. Speed is increasing gradually or
And the
gradually in the same direction, right? In one
uh,
direction. Yeah. That is linear acceleration. What about centripetal acceleration?
the speed does not change, but the direction changes.
Yeah. See here. This is angular acceleration. Yeah. Centripetal acceleration, what happens? Speed is changing constantly, but sorry, speed is same, but direction is changing
Direction
constantly.
changes.
Changes constantly. Whereas in angular acceleration, what will happen? Speed is also changing and direction is
Direction is also changing.
constantly. That happens in angular acceleration. So this is the difference between linear acceleration, centripetal acceleration, and angular acceleration. And what is the direction of the centripetal acceleration? What is the direction of the centripetal acceleration? Anyone? It is towards the center. Here, the direction of the centripetal acceleration is towards the center. Is that clear? So every time it is acting towards the center. Now, next one. So we will start new lesson. Okay, that is laws of motion. It's an interesting lesson. It carries more marks out. Okay, so now so here laws of motion. That is Newton's laws of motion. Laws of motion or Newton's laws of motion. So page 23. You know what is the significance of today's date? 23rd June. I think it's the longest day of the year. Is it?
No, sir, it's 21st June.
21st. 21st of?
June. Yoga day is longest.
No, not the yoga day. I mean.
It's the longest day, sir. Summer solstice.
Is it today or 21st?
21st.
21st. Okay. You can check on Google. Okay. Now, so laws of motion. So Isaac Newton has given 3 laws of motion. First law of motion, Newton's first law of motion. So what does it say? Newton's first law of motion. Newton's first law of motion. It says, what does it say? It says that a body remains to be in the state of rest or motion unless and until it is compelled by an external periodic force. Okay, body remains to be in the state of rest or motion unless and until it is compelled by an external periodic force. Mean, suppose if you keep your object on the table, it will be there for millions of years or there only, unless and until someone disturbs it or someone moves it from the place. Or if you throw a stone in the space, it keeps on going. It doesn't stop unless and until someone stops it or someone changes the direction of the ball. Clear? So this happens. This is the first law of motion. Once again, means suppose if your body is kept somewhere on the table, it will be there for millions of years unless and until someone disturbs it. Or if you throw a stone or a ball in the space, it keeps on going unless and until someone stops it or someone changes the direction of the ball. That is the principle on which the satellites are moving. So satellites don't require the fuel. Once they go into the space, they don't need any fuel. Once they go into the orbit. Okay, you know, if you look at the what do you call geostationary orbits and satellites, they make around geostationary is different, but the others are polar satellites. They make around in 80 minutes they complete one rotation. Means around 18 times they can see the moon in a day. Okay, so the 80 minutes or 84 minutes, they complete one rotation, okay, around the Earth. So that's so fast without any fuel, okay. Now, so next one is, for Newton's first law of motion gives the concept of friction and inertia, okay. First is friction, second is inertia. What is friction? Can anyone say? What is friction? Yes. Don't sleep, okay. After later on, after lunch, you can stay. Come on. Tell me what is friction. This is in grade 9 you studied.
Opposition to the motion of the body.
Very good. Opposition to the motion of the body. Opposition to the motion of the body is said to be friction. Okay. Opposition to the motion of the body. Motion of the body is said to be friction. Okay. So here we have, how many types of frictions we have? Types of friction. How many? Types of friction. What are they? Number one is static friction. Number one is static friction. Yes. Okay. What is static friction? Suppose this is the body. M is the mass of the body. Okay. This is a free body diagram. M is the mass of the body. Now, F is the applied force. And Fs is what? Frictional force. Fs is the frictional force, static friction. Clear? Now, if the applied force is less than the frictional force. Now, suppose this is the table. I'm trying to push the table. It's not moving. I'm trying to push the table, but the table is not moving. Means my force is less than the frictional force. My applied force is less than the frictional force. So that is why it's not moving. So here, the acceleration of the body is 0. Applied force is less than the frictional force. Okay. Here what happens? Mg is acting downwards and normal reaction is acting upwards. Okay. See, if only one force is acting at one time, suppose you are sitting on the chair. You are on the chair. And the chair has to sink. Only one force if it is acting, only weight is acting downwards, then the chair has to sink in the ground. But it doesn't happen so, right? The building has to sink, but it doesn't happen like that. Why? Because there is an equal and opposite force which is acting vertically upwards. Understood? When the weight is acting downwards, normal reaction is acting upwards. So that happens in the static friction. Is that clear? Is that clear?
So what is the force that acts upwards?
Force, normal reaction. That is N is normal reaction. So Mg is what? Weight. Mg is weight of the body. N is normal reaction. Normal reaction. Okay. And capital F is what? Applied force. The force what you have applied. That is applied force. And small f is what? Frictional force. Static friction. Okay. I will write here static friction. Fs is said to be static friction. Now, how do we write that? Fs is equal to mu s mu into n. Mu s. What is mu? Mu is said to be again coefficient of static friction. Means it depends on the roughness of the surface. Means like we say cold wedges, right? When you see the surface at microscopic level, you have zigzagness on the surface. There's said to be cold wedges, right? Do you know that cold wedges? What do you mean by that? Like suppose if you see a smooth surface at the microscopic level, it won't be a straight line, but it would be like zigzag surface. So this type of thing is removed in lenses, especially while grounding the lenses. Okay. So now, so coefficient of static friction. So that is why whenever you buy a lens or a specs, you need to buy a branded one. Why? Because this roughness of this, you will get the same first piece of the same brand, yeah, for the low cost also, maybe low cost. But why? Because here the roughness of the surface is not removed in the first piece. So that is grounded at in the branded ones. Okay, that check it properly. So this really means a lot for the eye. Okay, if the eye is having, if this is there on the lens surface, then your power of the eye can increase. Understood? So okay, forget about the lenses. Go back to the surface. Okay, if there is the roughness of the surface gives rise to friction. So Fs is said to be the static friction. Capital F is the applied force. Mg is the weight, N is the normal reaction, and acceleration is 0. You are trying to push the body, but the body is not moving. Okay, so the friction is said to be static friction. Understood now? Is it clear, all of you? Is it clear, all of you? Okay.
Fs is equal to.
Not getting. Can you say it again, please? Little loud.
What is the Fs is equal to ms?
Fs is equal to mu s into n. Fs is equal to mu s. Mu s is said to be coefficient of friction. It doesn't have any unit. It speaks about the roughness of the surface. Mu s speaks about the roughness of the surface. It speaks about how rough it is. Roughness of the surface. Okay. Roughness of the surface. Is it clear? Like it doesn't have any, maybe it can be like this. The value can be 0.02, 0.04, something like that. Understood? Example. Clear?
Yeah.
Okay. Please note down this. Then quickly we will move to the next second type of friction. Okay. Next is limiting friction. Limiting friction or maximum static friction. Fs max. Limiting friction or maximum static friction. I mean, suppose if this is the force, M is the mass, Mg is the weight, N is the normal reaction. Capital F is the applied force, and here it is Fs max. Means suppose if the applied force is exactly equal to the frictional force, if F is equal to Fs max, okay, applied force is equal to frictional force, then what happens? Still the body cannot move. The body is just about to move. The body is just about to move. Once again, see, if the applied force is exactly equal to the frictional force, then the body is just about to move. It's not moving, but just about to move. If you apply little force, so that friction is known as static friction. Here we say Fs equal to known as Fs max. So this is said to be limiting friction. Here I will write if the applied force is equal to the frictional force. Applied force is equal to the frictional force, and the body is about to move. And the body is about to move. So such friction is known as static, that is limiting friction. Okay. Next one is third one. Kinetic. There are three names for this: kinetic friction, or sliding friction, or dynamic friction. Dynamic friction. Clear. So that is what Fk. Okay. See here, if you want to write Fs is equal to what? Fs max. We write equal to that. Okay. Now kinetic friction or sliding friction or dynamic friction means, suppose if M is the mass, weight Mg is acting downwards, N is the force acting, N is the normal reaction acting upwards, and F is the applied force, and here Fk is the kinetic friction when the body is having an acceleration. Means if the applied force is greater than the frictional force, if applied force is greater than the frictional force, we are pushing, and the body started moving, then that friction is known as kinetic friction. Now, A is the acceleration. So here we write if F is greater than Fk, frictional force. So F is greater than the frictional force, or we can write capital F minus small f equal to Na, resultant force. Capital F minus small f equal to the resultant force. Okay, is that clear? So we can write here F is equal to what? F minus mu k times of N equal to Na. F equal to F minus, see, applied force minus frictional force equal to the resultant force. Why did I write capital F before? There is a reason for that also. Why did I write here first capital F? I could have written small f also before, but you have to look into the direction of the acceleration. Look at the direction of the acceleration. The direction of the acceleration, if you look, direction of acceleration and the applied force are in the same direction. So that is why applied force minus frictional force is the resultant force. Applied force minus frictional force is the resultant force. Is it clear? Is it clear?
Yes.
Yeah. So now I'll write the definition for this. If the applied force, is greater than is greater than the frictional force. Is greater than the frictional force. Okay, frictional force. The body starts moving. The body starts moving. The body starts moving. And there is a resultant force. There is resultant force. Okay. So capital F minus small f is equal to mn. There's a resultant force. Clear? This is kinetic friction. Last one is a rolling friction. Okay, just quickly write this one, then we'll go to the rolling friction. Yes. B. What do you say? Other girls? Yes, Roma. Should it be A or should it be B? Other girls, no one is trying this. Yes.
So can you repeat the question?
I mean, the body is rolling on the surface of the road, like a tire rolling.